Okay, you have also been introduced to the type of hybridization. So the type of hybridization depends on the electron groups or electron pairs surrounding the central atom. So we have 5 types of hybridization. We have SP, Sp2, Sp3, Sp3d, Sp3d2. Okay, all right. So basically, to draw or to represent the orbitals, the hybrid orbitals, you would draw it in this way. Maksudnya, it should be in lobes. Okay, lobe shape, and then the geometry is based on the electron geometry of the molecule. Okay, all right. So this is Sp. We know that Sp is linear, so we shall draw the hybrid orbital in linear form. So it has 2 lobes. Okay, 2 lobes. So these represent the orbitals, the hybrid orbitals of the molecule. And then this is trigonal planar because it has 3 hybrid orbitals. So it should be in trigonal planar shape. Okay, and so on. We have Sp3, Sp3d, and Sp3d2. Okay, all right. So, today we are going to look at each of the type of hybridization. Okay, we're going to start with Sp and moving on to Sp3d2. All right. So just to highlight that I have made some rearrangement of the slides because I feel that it's very important in terms of for you to better understand the hybridization. Okay, alright. Sebab nak bagi dia nampak structure teratur. Okay, I'm going to start with SP. Okay, and then Sp2, Sp3, and moving on to Sp3d2. As you can see in the slides, they start with Sp3. Okay, so that's why I've made some arrangement to the slides so that kita start from Sp and then moving on to Sp3d2. Okay, it's just that I'm going to divide into few groups. Okay, all right. So let's have this one. So this is the new. Okay, the new rearranged slides. So basically all these slides are from the original slides just now. It's just that saya rearrange saja. So there's no additional slides added. Tak ada slide yang baru. It's just that saya rearrange. Okay, alright. So we're going to start with SP. But before that, I would divide the type of hybridization into 3 classes ataupun 3 categories. Again, this is to nak bagi you guys nampak dia punya flows lah. Okay, dia punya flow so that you can I hope that by rearrange this slide this way you'll be able to understand it better. Okay, right. So the hybridization we are going to look at in terms of 3 category. Okay, we're going to start with all bonding electrons ataupun all bonding single bond, all single bonds in the molecule. Okay, so we're going to start with single bond. That means there's no lone pair, there's no double bond or triple bond. We have only single bond in the molecule. So what is the hybridization looks like? Okay, and then moving on to next we have molecule having lone pair. Okay, having lone pair or lone pairs. So what is the difference between having single bond only and single bond and lone pair? So what is distinguish between single bonds and lone pairs in terms of hybridization? Okay, and then last but not least, when the molecule having multiple bond. Okay, so it's either double bond or triple bond. Okay, so saya classify them into this category. So we're gonna start with single bond first, and then kita moving on to lone pairs and multiple bond. So saya divide in terms of this. Later kita akan go through very quickly on the original slides. Okay, kenapa saya tak go through based on the original slide? Instead saya rearrange them. Okay, alright. Okay, so we're gonna start. Okay, all right. Bismillahirrahmanirrahim. Okay, let's start with the first type of hybridization, Sp. So this is the hybrid orbital between S orbital and P orbital, 1p orbital. So example that we can have for Sp type of hybridization is beryllium hydride. Okay, beryllium hydride or beryllium dihydride. Okay, so the orbital diagram. Okay, all right. So from looking at the beryllium, so this is the beryllium. Okay, remember for the hybridization, the one that form the hybrid orbital will be the central atom. Most of the time, it will be the central atom that will form the hybrid orbital. Okay, but we do have terminal atom that will form hybrid. Okay, so normally it would involve multiple bond, which will be covered later in the slides, right? Okay, so beryllium. So we're going to start with beryllium. So ground state is the original state. Okay, the original state before it forms hybrid. So this is the normal form of beryllium in terms of the orbitals. Okay, so we call it as ground state. All right, so originally beryllium has 2 valence electron in the s orbital because beryllium comes from group 2, right? Okay, so this is the original form of valence electron in s sublevel. Okay, in the valence shell, which is kalau to be exact, this is supposed to be 2s, and we do not have any electron in the p orbital for beryllium. Okay, all right, so it will form Sp hybridization. We have determined this earlier. How do we know so? Because we have the Lewis structure. Okay, we have the Lewis structure ready, so we can count the number of electron group 1, 2, so it has 2 electron group, automatically it will be Sp. Okay, so kita dah tahu awal dah Sp. Alright, so next step is to prepare this Sp orbital. How do we prepare this Sp orbital? Okay, alright, so kalau daripada dia punya Lewis structure, we could see that in order for beryllium, okay, to form a bond with hydrogen, we have 2 hydrogen that will be forming bond with beryllium. So by right, beryllium should prepare 2 unpaired electron. Betul tak? So that hydrogen can be can form bond with beryllium. Tapi kalau ground state of beryllium, as you can see, there's no unpaired electron. There's no single electron for hydrogen to overlap with. Tak ada. So in order to prepare that unpaired electron, beryllium need to undergo hybridization. But before dia hybrid, dia kena excite dulu. Okay, so this one will be excited into the p orbital. Okay, hence we have Sp kan later on kan. So this will be our reference. Okay guys. Okay, so transfer 1 electron from s orbital to the p orbital, and then it become like this. This is what we call excited state of beryllium. Okay, and then the hybrid part is when the S and the P just now combine into forming the new hybrid orbital that is known as Sp orbital. Okay, all right. So that's why Sp need to be determined early. Okay, you have to determine the type of hybridization first, so that you can use this type of hybridization to prepare the hybrid orbital. Yeah, all right. So this is the Sp, the formation of Sp hybrid orbital. Okay, this is the Lewis structure, and this is what we call orbital overlap in terms of orbital, guys. This is in terms of orbital diagram. This is in terms of orbital overlap. Okay, because kenapa? Because we know in order to form bond, okay, the orbital need to be close to one another and finally overlap. So, one of the way to represent this orbital overlap adalah dengan cara by drawing this orbital overlapping. Okay, alright. So how do we draw this orbital overlap? Senang saja. Okay, so SP maksudnya kita ada satu tambah satu is equal to 2. So you should have 2 lobes. You kena ada 2 cuping. Okay, alright. So 1, 2. This is for beryllium. Okay, this is for beryllium, and then hydrogen. So it combines with hydrogen kan. So hydrogen should be bulat lah. Okay, sebab dia punya valence orbital, dia punya valence, yes, valence orbital is S orbital. Okay, alright. So we have the orbital overlap already. So now we have to show the electron. So we have 1 electron from beryllium. Sorry, saya tukar kepada color lain So kita tukar kepada biru lah. Okay, biru. Okay, alright. So 1 electron from hydrogen. Don't forget to label. Okay, alright. So this is also hydrogen, the second hydrogen, and we have 1 electron from hydrogen and 1 electron from, sorry, ni bukan macam ni. Dia betul begitu. Okay, 1 electron from beryllium. Okay, alright. As you can see, you may use your what do we call this, your Lewis structure in order to help you to draw the orbital overlap of BeH2. Nampak tak? Okay. Alright. So dia kena tiga-tiga kena serentak. Dia kena tally. They should be aligned. Okay. Alright. Imagine. Okay, kita start from the beginning. Let me erase this first. Okay. SP kan. So now we have the SP orbital for beryllium. Okay. Look at the orbital diagram. We have SP orbital for beryllium. So imagine if we have hydrogen. So this is hydrogen kan. It is 1s orbital, 1s another hydrogen. Okay, so this one will later be combined with the electron in the sp orbital. Okay, so inilah we prepare this hybrid orbital for hydrogen to be overlap, for the orbital to be overlap and finally form a bond. So this is the bond that I have mentioned just now. So this type of bond is known as sigma bond. Kenapa dia single kan? Okay, so this is the same as, okay, kalau this is sigma, nampak tak Lewis structure dia? This is sigma and this is also sigma, betul tak? Okay, so kalau saya nak tally kan, nampak saya nak tunjukkan tiga-tiga ni, orbital overlap ni, they are aligned with one another. Okay, alright. So Lewis structure, this is sigma, sigma. And how about the orbital overlap? Saya nak guna yang atas ni ke yang bawah ni? Guna yang bawah lah saya buat ni Alright. So this is also sigma. Tempat yang dia form bond, dia overlap tu will be the bond form. Okay. So this is also sigma. Okay, nampak tak dia tally Saya connect them nak menunjukkan dia tally orbital diagram. So this is the first sigma just now. Nampak tak? Dia sama dekat Lewis structure. And also the same with this orbital overlap. Nampak? Okay. Alright. This one yang dia form this apa nama tu sigma with hydrogen just now. This bond is the same as this bond on Lewis structure, guys. It's the same. Bukan saya tunjuk yang ni this one. Okay, this is the bond form for the Lewis from the orbital diagram. Okay, it is aligned with the Lewis structure and also aligned with this orbital overlap. This is sigma. Okay, Nampak tak? Tiga-tiga tu dia tally. Faham tak? Okay tak so far? How are you guys doing so far?
Okay.
Yeah, alright. So you kena make sure tiga-tiga dia tak boleh you choose one, you decide to go for orbital diagram only, not for orbital overlap. Tak boleh. It depends on the question. The question may ask in terms of orbital overlap, or it can also ask in terms of orbital diagram, or sometimes even both. So you kena tahu dua-dua lah. Okay? Alright, moving on. So that is SP for single bond dulu. Okay, for single bond. Later we also have SP for multiple bonds. Okay, let's just settle for single bond first. So nampak tak dia punya pattern for single bond, all should be unpaired electron. Okay, moving on. Mungkin lebih banyak lagi contoh so that you boleh faham. Alright, so now moving on to Sp2. Okay, so Sp2, that means we have one s orbital plus 2 p orbital. Is in total we have 3 orbitals, 3 hybrid orbitals. So these represent 3 electron groups on the central. Okay, how do we get Sp2? Senang saja, because we can just count ataupun total up the electron group on the central. So 1, 2, 3. So 3, so it should be Sp2 lah. Okay, it should be Sp2. As simple as that in order to determine the type of hybridization. So from this Sp2 that has been determined earlier on, kita akan use this information to help us to guide on how to prepare the orbital diagram. Nak prepare the orbital diagram. Okay? Alright, so Sp2 tu kita hold dulu, kita simpan dekat situ dulu. Alright, so katakanlah the question asks you to prepare ataupun draw the orbital diagram for the hybridization of BH3. Of course, you have to have your Lewis structure. Okay, Lewis structure is needed in order to determine the type of hybridization, Sp2 just now. Okay, we're going to start with the ground state of boron. Okay, you kena tahu the valence electron for boron. How many valence electron for boron? So boron comes from group 13. Therefore, it should have 3 valence electron. Okay, all right. So this is the ground state of boron. So we have 2 electron in the s orbital and 1 electron in the p orbital. Okay, this is the original state. All right. So okay, logically speaking, kalau kita tengok dia punya Lewis structure just now, from the Lewis structure, okay, we should have an idea that boron need to share 3 of its electron with 3 hydrogen. Nampak tak? Dia kena share with 3 hydrogen. So by right, boron should prepare 3 single electrons so that the single electron from boron can be combined with the hydrogens electron, with 3 hydrogens electron, okay, from 3 hydrogen atom. Yep. Okay. Tapi when we look at the ground state of boron, we have only one. Boron has only 1 unpaired electron. Okay, boron has only 1 unpaired electron. So how do we prepare boron's valence electron so that all of them should be single electron ataupun unpaired electron? Okay, first you need to be promoted dulu, excited. Okay, alright. So this one will be excited into the p orbital and becoming this. Nampak tak? So ada 3 unpaired electron. Now this is excited state only. Okay, in order to form hybrid. Hybrid apa tadi? Sp2. Okay, so this S need to combine with 2p orbital. Okay, so not only dia lompat, it need to be combined and becoming Sp2. Okay, it need to form Sp2. So this is the hybrid orbital for boron. So later you can imagine that hydrogen, there will be 3 hydrogen, okay, will combine with this unpaired electron from boron. So the first one, and second one, and the third one. So you can imagine lah. So the first bond will be sigma, the second also will be sigma, the third bond will also be sigma. Boleh imagine macam tu lah. Okay, alright. So how do we draw the orbital overlap, guys? How do we draw this? Okay, saya start from the beginning. Let's have green color for boron. Okay, so we know that it is Sp2, right? So Sp2, that means we have 3 lobes. 1 s orbital plus 2 p orbital, that means you have 3 lobes, 3 cuping. So 3 cuping means 1, 2, 3 in trigonal planar form. So this is for boron. Okay, this is for boron, and then it will overlap with hydrogen. So remember, for hydrogen, it should be round. Okay, the orbital should be round. You should draw the orbitals in round shape because kenapa the electron is in s orbital. Okay, so kita buat round, and don't forget to add electron. Okay, saya tunjuk color lain lah. So merah will be hydrogen. So make sure that you label. It is very important to label your drawing. The green just now, okay, come from boron. Okay, all right. So that will be your orbital overlap. Okay, saja je saya nak menunjukkan yang that orbital diagram, the Lewis structure and orbital overlap, they should be tallied. Okay, they should be aligned with one another. Okay, so kita connect guna apa? Color hitam, color biru lah. Okay, alright. So label, this is Lewis structure kan? Okay, so this is sigma bond, this is sigma bond, this is sigma bond. Alright, how about the orbital overlap? Okay, so this is sigma bond. The tempat, the region that they overlap will be the sigma. Okay, sigma and sigma. So kalau saya nak connect them, okay, please bear with me. Mungkin dia akan jadi messy, tapi make sure that you nampak lah apa yang saya nak try, nak tunjukkan. Eraser, delete dulu this one. Okay, alright. So kita pakai color apa? Nak pakai color biru pekat ni. Alright, so this first what do we call it? First sigma bond. Okay, saya nak jalan ya. Okay, is the same for this sigma bond dekat sini, dekat Lewis structure sama and also the same as the sigma bond for the orbital overlap. Faham tak? Dia tally, dia sama. Cuma dalam untuk orbital diagram, and we have Lewis structure and also in terms of orbital overlap. Okay, alright. The second sigma bond on the orbital diagram here, the second sigma bond, kita ada 3 hydrogen. Okay, so this one will be the same as this on the Lewis structure and also the same as this. Mana-mana nak tunjuk pun tak apa. Okay, the same as this, okay, on the orbital overlap. And the third sigma bond will be the same as this and also the same as this. Dia agak messy sikit lah, tapi saya nak connect them. Okay, nak connect them so that you nampak that they are actually aligned. Okay, right. Okay ke so far? How are you guys doing there? Okay.
Yes,
Madam.
Yes, madam.
Okay, very good. Okay, moving on to Sp3. Betulnya you dah dapat dah idea tu lah. Okay, alright. So Sp3, so this is the Lewis structure. You're gonna start with Lewis structure. It's forever will be Lewis structure for the first and foremost step. Okay, mesti Lewis structure. Okay, alright. So how do we determine the type of hybridization? So basically we just count the number of electron group on the central. So 1, 2, 3, 4. So we have 4 electron group, which equal to Sp3. 3 plus 1 is equal to 4. Okay, that means we have 4 electron groups on the center. Okay, alright. So nampak je from the Lewis structure, we should know that by right, the carbon should prepare 4 unpaired electron available so that the hydrogen can form bond with electron from carbon. Okay, so logically speaking. Tapi bila kita tengok the ground state of carbon, okay, original carbon, original what do you call that? Electron configuration or orbital diagram for carbon. Initially, carbon has only 2 unpaired electrons sahaja. Maksudnya hanya 2 hydrogen can form bond with carbon. But we need to hydrogen. We have 4 hydrogen. Okay, the carbon need to accommodate 4 hydrogens atom. So how do carbon accommodate all the 4 hydrogen? So in order to do so, one of the way is by forming hybrid orbitals. Okay, all right. But before the hybrid orbital can be formed, the electron need to be promoted ataupun need to be excited into the p orbital. Okay, all right. So this is the ground state for carbon. Carbon has 4 valence electron. Okay, 1, 2, 3, 4. And then next excited state, this electron will be promoted into the p orbital. Okay, into the vacant p orbital here. So it become like this. Okay, all right. And then in order to form the hybrid orbital, the s and the p orbital need to be combined. So dia ambil semualah. So dia jadilah begini. Okay, all right. So now the carbon, okay, the hybrid orbital for carbon is now ready for bond forming, okay, with hydrogen. Okay, so you can imagine that hydrogen can form a bond with this one. Okay, so kita nak start from ni kan. Kita nak tunjukkan okay, the messy part. So kita ada 4 hydrogen. Okay, so this is 1s. Okay, so this is the first sigma bond, and then the second, the third, and the fourth. So these are all sigma. Okay, buat kala biru, sigma lah, nak tunjuk biru sigma bond. Okay, the formation of sigma bond in terms of orbital diagram. So how do we draw the orbital overlap for sp3? Okay, all right. So in order to form the orbital overlap for sp3, you're going to start with carbon dulu. For CH4, for CH4. Kita start from the hybrid orbital of carbon. Okay, senang, sama macam tetrahedral. Okay, so it should have 4 lobes. Mana nak buat sini kot. 1, 2, 3, 4. Okay, right. So we have 4. So this is carbon label. So each one of the loads should consist of the electron, the single electron, which later on will be overlap with the hydrogen orbitals. Okay, alright. So pilih color apa? Hijau. This is hydrogen, hydrogen, hydrogen. Banyak contoh hydrogen Nanti takut awak asyik-asyik buat hydrogen je. Bila bagi F ke CF4, lupa. Pergi buat bulan lah. Bila F fluorine dia p orbital, so you kena draw macam ni. Okay, should be p orbitals. So hydrogen kebetulan dia adalah bukan kebetulan, hydrogen the valence electron in it is in s orbital. Okay, alright. So don't forget the electron, guys. Yep. And label hydrogen, 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 and not to forget the sigma bond. So this is the sigma bond. The part that overlap is sigma bond. This is also sigma, and this is also sigma. Okay, alright. Okay, cuba kita let's have the the Lewis structure here so that it is closer, so that kita boleh connect them. For the Lewis structure, this is also sigma, 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 sigma. Okay, so cuba kita connect them. Let's have black color. Okay, ready ya? Okay, bear with me. Alright, so the first sigma bond, which is this one. Okay, alright, kita pergi Lewis structure and then orbital overlap. Okay, orbital diagram, Lewis structure, orbital overlap. Orbital diagram, Lewis structure, and then orbital overlap. Okay, so the first sigma bond from the orbital diagram is the same as this one. Kat mana? Sini. Pilih mana-mana lah, sama je. Sini, and then which also the same as this one. Mana nak pergi ni supaya tak messy sangat. Okay, tak apalah, sini. Okay, this one. Okay, so this is the sigma bond. It's a line, maksudnya dia benda yang sama lah, cuma in terms of representation. Okay, the second sigma bond will be from this one, okay, which is the same as this one, and this one also is the same as this one. Yang this one. Okay, apa benda this one, kalau lost memang awak takkan faham lah. Okay, alright, so kalau yang ini, this is this apa sigma bond, which also the same as this one. And last but not least, the fourth sigma bond is this one yang kat atas ni, and also the same as this one. Okay, saja je saya nak connect them, nak menunjukkan yang dia correlate ataupun align. Tapi dalam exam tak perlu pun tunjuk dia macam tu, unless you are asked to do so. Okay?
Madam, tapi simbol sigma tu memang kena letak lah kan? Ke tak perlu juga?
Normally, dia depends on the question. Kalau soalan tak tanya, show the sigma, the formation of sigma bond, then tak payah letak lah. Normally we don't include lah. Unless kalau dia minta, then you memang kena bagi. Kalau tak minta, you include, tak apa. Tapi tak ada markah lah. Okay? Selalunya dia akan mention and show the formation of sigma bond ataupun show, connect the orbital diagram and show the formation of sigma bond. Macam tu. Dia selalu akan minta for the formation of sigma bond ataupun pi bond. Okay? Jadi kalau tak minta you bagi, tak apa, tak ada masalah, tapi there's no mark for it. Okay? Faham ya? Right.
Madam,
Madam.
kiranya Lewis structure tu kita lukis 2 kali ke?
Sorry?
Satu yang untuk yang Lewis structure tu kena lukis 2 kali ke? Satu
Tak adalah,
yang bawah
mana yang ni?
SP3 tu.
Satu kat sini.
Lewis
Taklah,
structure.
saya alihkan dia dekat sini so that it is closer. Okay? So that it's closer. Tapi you ada satu Lewis structure cukup dah. Right? But normally guys, the question will ask you to show the formation of hybrid orbital for carbon for CH4. Then you draw ini sajalah. You draw this part saja. Okay, ataupun soalan tanya show ataupun draw the orbital overlap for CH4. That means you kena draw yang ini sajalah. Faham tak? Saya ni buat kerja ekstra, okay, just nak tunjukkan the three of them, the Lewis structure, the orbital diagram, the orbital overlap, they are aligned. Faham tak? Dia tally. Okay, so maksudnya dia Lewis structure tu bukan saja-saja suka buat macam tu, dia kena align, dia kena tally dengan orbital diagram, dengan also orbital overlap. Faham tak? Tapi bila dia tanya soalan, dia nak minta orbital diagram, you tak payahlah tunjuk macam apa yang saya buat ni. Okay, sebab dia akan jadi messy, tak perlu. Ini saja saya bagi extra information. Faham tak? Okay
Faham, Madam. Thank
Okay,
you, Madam.
alright. Depends on the question, okay? Alright. Okay. 2 more, okay? SP3D example is, we have example PCl5. So PCl5, when we draw the Lewis structure, this is how PCl5 looks like. This is the Lewis structure for PCl5. Okay, all right. So from the Lewis structure, we are going to determine the type of hybridization, okay, based on the number of electron group present on the center. In this case, phosphorus. So we have 1, 2, 3, 4, 5. So we have 5 electron group. 5 electron group is equal to Sp3D. 1, 3, 1. So in total, we have 5 electron group. Okay, Sp3D. Okay, tak ada SP4 Lagi sekali saya ulang suara. There's no SP4, SP5 and so on. Tak ada. It should be SP3. The maximum for P would be 3, SP3, and then we go for D. D1, D2, D3 and so on. But sorry, D1, D2. So far kita ada maximum sampai D2. We don't have D3. Okay? Alright. Okay, so kita start. Kat sini tak ada the orbital overlap. Okay, tak apa. Lagi bagus, kita senang nak tunjuk. Alright, so gonna start with phosphorus. Phosphorus come from group 15. That means phosphorus has 5 valence electron. Okay, so we have S, a full-filled orbital S, and P, we have 3 unpaired electron in P orbital. Okay, alright. So phosphorus is located below nitrogen. Okay, so familiar nitrogen macam ni kan, phosphorus pun sama because they have the same number of valence electron. Okay, alright. So kita prepare D dekat sini. Even though it is vacant, we still prepare the D orbital. Kenapa? Because earlier on we have predicted that the type of hybridization is Sp3D. So that's why kita prepare the D orbital even though it is vacant, because later on we will transfer the 1 electron, we will promote the 1 electron into the D orbital. Okay, alright. Okay, so kita dah tahu Sp3D kan, so kita nak prepare Sp3D ni macam mana. Okay, kita cuba tengok the Lewis structure. So phosphorus by right have to prepare 5 unpaired electron so that the chlorine can form bond with phosphorus. The 5 chlorines atom can form 5 bond with phosphorus. So at the moment, as you can see from the ground state of phosphorus, phosphorus consists only 3 unpaired electron. Tu tak cukup lagi 2. Alright, so to prepare the 2 unpaired electron, another 2 unpaired electron, so the S orbital here need to be promoted into the D orbital, guys. It need to be promoted into the D orbital, okay? And then finally, as you can see, we have all the electrons are unpaired, okay, in single form. So they unpaired, then they kena combine. So this is only promotion of electron, okay? Next, the orbital need to be hybrid ataupun need to be combined and finally form this Sp3D. Okay, dia ambil semualah, kebetulan dia ambil semua. Okay, ni Sp3D. Now bolehlah Cl form bond with all the 5 Cl atom form bonds with what do we call this? With phosphorus. Okay, alright. So imagine Cl dia punya the highest sub level is Cl come from period 3. So dia punya what do we call that? Dia punya valence shell adalah 1, 2, 3, 3p, betul tak? 3p, 1, 2, 3, 4, 5. Dia sebenarnya ada 3s dekat sini, tapi tak payah tunjuk pun tak apalah. Okay, so 3p. So nampak tak dia ada single dekat sini, single electron. So we have 5 fluorine atom. Oops. Okay, so we have 5 chlorine atom dekat situ. Okay, alright. So this single electron will overlap with the single electron from phosphorus. Okay, alright. So kita pakai color lain. Okay, this one. Dia, bayangkan ada 5 ada 5. Saya malah nak tunjuk 5 tu. Okay, so dia akan form single bond with the first one. So this is sigma, and then the second sigma bond, sigma, the third sigma bond, they combine, they overlap. This is also sigma. And then sebenarnya kena buat 5 lah chlorine tu sebenarnya. Okay, sebenarnya. Last one would be this one, sigma. Okay, alright. Sama tak dengan kita punya, what do we call this, Lewis structure? Sama, ni semua sigma, 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 sigma. Alright, so the best part is how do we draw the orbital overlap for PCl5? Okay, alright. So PCl5 is trigonal bipyramidal in shape. Okay, the shape is trigonal bipyramidal. Okay, macam biasa saya kan suggest hari tu buat orang kan. 1, so you should have 5 loops. Okay, 5 loops. 2, 3, 4, 5. Okay, so this is the phosphorus. Okay, right. So the electron on each loop. Alright, done. Okay, next. Okay, the terminal atom. So let's use blue color. Right, so this time around it's no longer a circle. Okay, we are no longer using circles. Instead, we are going to be using the lobes. P orbital macam mana? Begini kan? Yep. Tunjuk satu je cukup lah. Okay. Kenapa begini? Sebab dah tunjuk tadi. The sub level, the unpacked electron tu duduk dekat P orbital. Don't forget, okay, the electron from chlorine. Dia kena pair dengan chlorine. Bukan ke atas, ke bawah. Ayo. Ayo. Ayo, yo. Okay, alright. And then blue tadi. Buruk lah. Tak apalah. Okay, alright. So this one pointing downward. This is also downward. Downward. Okay, from chlorine. Okay, alright. Make sure you label Cl, 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 Cl. Right? Okay, sigma. Okay, so the region that they overlap will be the sigma bond lah. Okay, sigma. This is also sigma. 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 So saya tak nak tunjuk lah. So you fahamkan tadi macam mana nak buat dia connected ataupun nak tunjukkan the alignment of orbital diagram, the orbital overlap and also the Lewis structure. Okay? Right, done. Last but not least, patutnya you dah by now you dah ada idea lah. Maksudnya you dah tahu dah. Kalau single bond, you boleh nampak lastly you will end up with this. All single unpacked electrons are combined. Okay, so kalau Sp3D2, for example, sulfur, we can predict this from the number of electron group surrounding the central atom. So we have 6 electron groups. So automatically it will be Sp3D2. K3 plus 1 plus 2 will be 6, which is the same as the number of electron group on central. Okay, all right. So initially, this is how ground state of sulfur looks like. So by right, sulfur need to prepare berapa banyak unpacked electron? 1, 2, 3, 4, 5, 6. Ada 6 fluorine. Okay, that need to form bond with sulfur. So by right, sulfur have to prepare 6 unpacked electron in order to form bond with fluorine. So initially, okay, at the ground state, fluorine has only 2 unpacked electron. So kena prepare lagi 4 unpacked electron. Okay, alright. So kat sini dia ada 2 yang dah fulfill kan. So the 2 electron from the fulfilled orbital, bukan the 2 electron, the electron from the fulfilled orbital will be promoted into the d orbital. Okay, alright. So this one will be promoted. The first promotion, the second promotion will be this one. But dia dah fulfill kan, and then this is how it looks like. So all of them are unpacked electron. Okay, this is in excited state, and then they will combine in order to form Sp3D2. Okay, alright. So single bond lah. So all of these will be single bond because from the Lewis structure pun kita boleh predict all of the bond form are single bond. The first bond mesti single bond. Okay, alright. So how do we draw SF6 in terms of orbital diagram? Okay, let's draw the sulfur first. Okay, so we have six apa nama tu, we have 6 electron group kan. Okay, so let's draw 6 lobes, 6 cuping. Okay, macam mana nak draw 6 cuping? 1, 2, 3. Lagi satu. Yap. Buruk sikit lah Okay. Alright, so this is sulfur. You don't forget the electron, the unpaired electron on each lobe. Okay, alright. So how do we represent fluorine? Nak tunjukkan the formation of sigma bond between sulfur and fluorine. So fluorine again, the highest sublevel, the valence electron in the highest sublevel would be in p orbital. Betul tak? So p orbital shape dia macam ni. Sini. Okay. Excuse my apa nama tu? My bad drawing lah. Okay. Okay. So make sure that you show the electron from fluorine. Okay. So dekat tempat overlap tu. Then don't forget to label. Salah kat sini. Okay. And then sigma. Sigma. Kalau you dah biasa buat sigma, tak apa, tak ada masalah. Okay. Tunjuk je lah sigma bond. Tapi kalau dia suruh, memang wajib lah tunjuk. Okay. Alright, so we are done with all single bonds. So let's go back to the first slides here. So we are done with this one. Okay? Alright, any question related to single bonds, guys, so far? Okay ke?
Okay.
Okay.
Okay, madam.
Okay, madam.
Saya ada soalan, madam.
Very good.
Yang kenapa madam lukis yang S orbital tu macam P orbital? Sama je. Bukan S orbital spotnya sphere ke?
Yang mana? Kat mana? SP?
S orbital.
S orbital. Kat mana? SP3D tu ke? Is it? Ya.
Ya.
Mana S
Bukan-
orbital?
Yang SP3D2 tu. So
Ni.
lukis dia.
Dekat orbital overlap ke?
Orbital overlap.
Mana tunjukkan saya mana S orbital. Patutnya tak ada S orbital di sini.
Oh, ya.
Mana S ni?
Sebab elektron tu dekat S orbital kan? Satu.
Mana ada fluorine. Fluorine dia punya valence orbital dia dekat 2s and 2p, betul tak?
Maksudnya
Ini S kan?
yang sulfur madam.
Mana ni sulfur?
Sulfur.
Sulfur.
Ya, elektron tu dia kan distribute kan, S, P dengan D.
Ya.
Kan? Lepas tu satu elektron dekat S kan?
Satu elektron. Bila dia dah jadi hybrid ke begini? Tak ada, dia tak macam tu dah. Dia tak ada SP, dia dah tak ada S dekat satu S, tak ada. Dia dah jadi hybrid, dia dah combine hybrid. Maksudnya dia bukan lagi boleh you pecah-pecah jadi SP3D balik, tak boleh. Faham tak? Dia dah jadi, dia dah combine, so that's why you akan dapat begini. Terus dia dapat jadi apa? Ada 6 loop.
Okay.
Okay, dia sebenarnya bila dia combine tu, ya Allah. Okay, padam, mana nak padam ni kan, terpadam semua pula. Bila dia combine sebenarnya, tapi kita tak ada slide on that, okay. So this is P orbital kan, dia combine, dia hybrid with S orbital kan. When these two combine, dia akan jadi macam ni tau, shape dia. Besar and then kecil kat situ. Okay, this one, this combine. Lepas tu imagine ini satu probability. Okay, dia ada
Oh,
P,
yeah.
banyak P lagi kan dekat situ kan.
Ah.
Ada banyak P lagi kat situ, and then they overlap. Bila dia ada banyak yang begini rupanya, they overlap with one another, so dia akan jadi loops. Terus dia combine jadi dia
Okay.
terus jadi 6. Okay, alright.
Faham,
So
madam.
to simplify, so terus je go ahead and count the number of orbital combine. So S ada 1, P ada 3, D ada 2, so 6. So senang nak ingat, so patutnya you should have 6 lobes, 6 cuping, 3 atas 3 bawah. Okay?
Okay,
Madam, kalau kita direct based on dia punya bond tu je boleh ke? Macam tu kan ada 6 bond kan, kita test direct 6 bond, boleh juga ke?
Direct kira bond
Daripada
tu
Lewis,
ke?
daripada Lewis structure kan kita boleh nampak terus kan ada 6 bond. So kita direct terus ambil 6 slope, boleh ke macam tu? Ke
Boleh.
ada certain situation yang macam dia tak boleh nak ikut daripada bond tu?
Dia sebenarnya dia tak boleh, kita tak boleh pakai the term pakai kita kira bonding tau. Sebenarnya what we are focusing on is on the electron group. Okay, bukan more on the bonding side, sebab later kita nak belajar lone pair. Bila lone pair tu maksudnya dekat lone pair tu tak ada, bukan bonding, is lone pair, betul tak? So that's why sebenarnya kita bukan based on bonding, kita based on electron group. Okay, tapi kalau we reference to your question just now, we reference to SF6, ya betul, you kira the bonding. After all dia tak ada lone pair. Okay, you boleh pakai kira 6 bond tu, that means 6 electron group sebab there's no lone pair. Okay, tapi to be specific, it should be electron group on the central, dekat Lewis structure tu. Dia bukannya bonding. Okay, dia adalah electron group sebenarnya. Tapi with subject to SF6, dia adalah semuanya bonding.
Madam, so kalau for lone pairs kan, kalau untuk hybridization ni kan kita based on electrons geometry kan. Kalau kita ada lone pair, so kira dia still 6 group of electron kan. So dia still Sp3D2 ke macam mana? Ke sama?
Itulah kita nak tengok je lagi.
Okay.
Dia kalau dia ada lone pair, kita still counted sebab later kita akan tengok dia akan hybrid dengan siapa. Of course S akan ada, confirm S akan ada. So dekat S tu dia tak semestinya single. Tu yang kita nak tengok kejap lagi. In category of lone pair. Okay, molecules having lone pair. What is the difference between single bond and molecules having lone pair? Okay, alright. Okay, any question before we proceed to the next category?
Last. Untuk yang ni, dia just untuk 2 atom atau tak kisah berapa banyak atom dia gabung?
Dia untuk sebenarnya it's applicable to all central lah. Okay, kita cakap bukan 2 atom, kita cakap to central sebab dia depends on the central kan. So like I said last time, kalau dia ada more than one central, that means you should have more than one type of hybridization. Faham tak? So katakanlah you ada SF6, SF5 dengan Cl, tiba-tiba dia ada satu Cl. So one of the F is now being replaced with Cl. So maksudnya you just need to label satu daripada fluorine tu with Cl. Macam tu. Okay, so sebab dia still attached to the same central. Dia attached kepada same central. So just replace, and after all dia bukan, katakanlah dia adalah hydrogen. SF5 dengan hydrogen. That means you kena tukar this one with bulat. Faham tak? So dia menunjukkan dia still attached to the same central. Dia berbeza kalau you ada more than one central. Contohnya C2H2 yang kita buat hari itu. Betul tak? That means you ada 2 type of hybridization because you have 2 central there. Okay? So maybe kita boleh tengok kot, ada nanti dekat multiple bonds ataupun multiple bond kita ada contoh dekat situ. Alright? Okay, any other question before we proceed to the next category? Ada? Right. Okay, tak ada. Okay, now let's move on to molecules having lone pair. Okay, alright. So we have NH3 as our example. Okay, alright. So kita tak boleh nak decide dia ni mesti SP. Kita tak boleh start from SP2. Dia tak semudah macam tu. Okay, it's not as simple as that. Dia SP normally we don't. Do we have? Yes, we do have SP. Okay, SP type hybridization having lone pair. Tapi kat situ dia complicated sikit. Dia ada lone pair and dia ada multiple bond. So dia akan complicated dekat situ. Right? So that's why kita terus kepada SP3. Okay. Yang penting you nak identify what is the difference between molecules having lone pair dengan molecules having all bonding pair. Apakah tipsnya nak identify? Okay. Alright. So NH3 guys. NH3, you akan buat the Lewis structure. From the Lewis structure, you just count the number of electron group. So dia ada 4 electron group, betul tak? So bila you ada 4 electron group, so it should be Sp3. Right? So Sp3, so the nitrogen which is the central. So this is how nitrogen punya orbital diagram, the ground state of nitrogen. So we have 2 electrons in S orbital and 3 unpaired electron in the P orbital. So as you can see, basically nitrogen dah ready. Nampak tak? Dia dah ada 3 unpaired electron because nitrogen need to form bond with 3 hydrogen atoms. And nitrogen has 3 unpaired electron already dalam keadaan ground state dia. Okay, tapi dia still kena hybrid. Okay, dia tak boleh just simply hydrogen masuk and form bond overlap with nitrogen. Kenapa? Remember last time kita ada satu slide tu, kalau dia tak combine, okay, the geometry will be inaccurate. Dia tak sama dengan reality. Okay, the real molecules dia tak sama. Dia punya bond angle is not the same. Okay, bila dia hybrid baru dia sama. Okay, alright. So dekat situ, even though dia dah ready the 3 unpaired electron, the nitrogen still will form hybrid. So the type of hybridization would still be Sp3. Okay. Alright, so dia tak perlu ada promotion, so there's no excited state of nitrogen. Okay, tapi kita still tunjuk lah sebab you dah kita standardize kan, okay? Alright, so we have ground state, we have excited state, and then lastly we have hybrid state. So for nitrogen, so there's no promotion of electron into the p orbital. Okay, that means you just remain the initial ground state, you draw balik dekat its excited state. Faham? Sebab kita nak make sure dia standardized. Okay, tapi dia adalah benda yang sama from the ground state just now. Okay, not only that, dia baru dia hybrid. So dia hybrid. Dia hybrid S dengan P akan combine sebab dia nak jadikan Sp3. Mesti nak jadikan Sp3. Okay, alright. So nampak tak apa perbezaan dekat situ? Kalau dia ada lone pair, that means there should be one full-filled orbital. Faham tak? Nampak tak dekat Lewis structure dia begini, betul tak? That means this one, hydrogen akan masuk. Okay? Dia akan overlap with the electron from nitrogen. Dia akan overlap. Habis ni represent apa? This one represent the lone pair, guys. Okay? Faham tak? Itu je beza dia. Kalau you ada 2 lone pair, you can imagine. Maksudnya you boleh predict. You boleh predict. Okay, if you have 2 lone pairs on the center, that means you should have these this full-filled electron, full-filled orbital, ada 2 dekat situ. Kalau ada 2 lone pair. Faham tak? Alright, so how do you draw the orbital overlap? How do you draw the orbital overlap? basically you draw the same way as what we had earlier for the bonding electron, for the bonding pairs. Yang kita belajar tadi, maksudnya dia sp3 tu tak? sp3 that means you should have 4 lobes. You kena ada 4 cuping tu in tetrahedral shape. So 1, 2, 3, 4. Sama saja label, okay, bukan N. Okay, N. Alright, next dia combine dengan hydrogen. So okay, buat elektron dulu. Okay, and then hydrogen should be circle, kena represent dia bulat. Tapi ada 3 je jangan syok orang pergi buat bulat, semua nak bulat. Right. Oh, okay, lupa. This one. Dua-dua datang daripada nitrogen. Sebab dua-dua ni nitrogen punya ni. Okay, that's why saya buat both electron using blue ink. Okay, blue color ni kat sini. Label, alamak. Hydrogen. So this is sigma, this is also sigma, and this also sigma. Ini apa? Ni lone pair. Sama tak dengan the Lewis structure? Yes, it's the same. Right? Oh, ada tu keluar tu. Cuba saya iris. Alright, so this is the orbital overlap for NH3. So this one is for lone pair. Okay, this is for lone pair. Yeah, kalau in terms of orbital diagram, this is for lone pair. Sama tak dengan Lewis structure and orbital overlap? So they should be the same lah. Kalau you nampak tak sama, maksudnya you salah lah somewhere. Okay? Alright. Okay, another example, sp3d2, BRF5. Bila kita draw BRF5, okay, this is the Lewis structure for BRF5. Okay, so kita kira berapa electron group in order to determine the type of hybridization. 1, 2, 3, 4, 5, 6. 6 that means that 6 electron group, that means the type of hybridization is sp3d2. Okay, sp3d2 because we have 6 electron group. Okay, so let's draw the orbital diagram for the central, okay, for the bromine. Okay, so this is bromine punya valence electron. Okay, so we have 7 valence electron for bromine. Okay, so kita prepare the d orbital, even though it is not used, it is empty, we still prepare because kenapa? The type of hybridization is sp3d2, which means that later we will be using the d orbital. Right? Okay, bila kita tengok, kita ada 1, 2, 3, 4, 5. There are 5 bonds. Apa nama tu, on bromine. That means bromine should prepare 5 unpaired electron. Betul tak? And there is 1 lone pair dekat situ. So boleh imagine there should be 1 fulfilled orbital lastly. Okay, for the hybrid orbital. Okay, so kita nak prepare for the bond first. Okay, kita excitekan dia. And then jangan excite semua. Semua excited tu memang excited betul lah, awak excitekan semua. Okay, so bila you nampak lone pair dekat situ, please bear in mind, be careful. Okay, bila you nampak lone pair, that means you dah take note that during hybrid tu, last for the hybrid orbital, there should be 1 fulfilled orbital. So this one will represent the lone pair. So janganlah shock pergi semua pergi excited kan. Okay, alright. So kita hanya excitekan 2 saja kat sini. Malas no madam ni. This one. Okay. Okay, they're excited, so they become macam ni, nampak tak, single, and then you have to combine. Okay, dia undergoes hybridization, so this is the final hybrid orbital. Okay, alright, so you can see dia ada fulfill guys. Dia still combine dekat situ. Dia combine SPD, still combine. So maksudnya ada bila this is the hybrid form. So as you can see we have one fulfilled orbital. So this one fulfilled orbital represent the lone pair of the central. So yang ini nanti fluorine akan combine dekat sini. Fluorine akan overlap. The 5 fluorine. Okay? Right, so how do we draw the orbital overlap? Dia tak include maybe you can tambah in your slide. Tapi dia mungkin tak tahu. You kena selak-selak slide you sebab saya rearrange balik ni. Okay, green. Octahedral kan just now we have 6 electron group. That means you have 6. You should have 6 lobes. 6 cuping. Octahedral kan? 1, 2 atas bawah. 4. Aduh buruknya. Okay, cantik lah. Okay, alright. So this is S label. Is it S? No, it's BR. Allahu Akbar. So there should be 6 loop, okay? Alright, so this is BR. Astaghfirullahalazim. Okay, this is BR. Okay, and then don't forget the electron. Okay, you decide you nak mana. Okay, kita follow lah the Lewis structure. Okay, alright. Place all the electrons in the their respective loop. Okay, so here we shall have 2 electrons because this one represent the lone pair. Okay, right. Then red color. Fluorine. So fluorine has a P, apa nama tu, P orbitals. Okay. So dia macam ini. Macam tu lah masuk syok sendiri tu dia terlajak. Bertenang. Okay, label. F. Alright, so this is the lone. Jangan buat macam tu, madam. Okay, label. Right, label. This is dah label kan? Saja nak highlight kan? This is the lone pair, guys. Okay, alright. So that is the lone pair ni. Dia kena sama lah dengan your Lewis structure and also your orbital diagram. This is the lone pair. Sama tak? And also sama tak? Sama. Okay? Last but not least, ada banyak ke? Right. So itu if we have one lone pair. What about molecule having more than one lone pair? Sama saja konsep dia. Contohnya BRF3 when you draw the Lewis structure. So this is your Lewis structure kan. So we have 3 bonding pairs, 2 lone pair. Regardless, we just need to count the electron group on the central. So how many electron group? 1, 2, 3, 4, 5. So there are 5 electron group. So it should be Sp3d. 3 plus 1 is equal to 5 because we have 5 electron group. So it should be Sp3d. Okay, alright. So from the Lewis structure itself pun you dah boleh bear in mind, you dah boleh take note, you have to be careful. Okay, we have 2 lone pairs. That means at the end of the hybridization tu, for the orbital diagram, you should have 2 fulfilled orbital. Macam ini, nampak tak? Okay. Ini dia punya special characteristic for lone pair. Okay, macam biasa you prepare bromine. Okay, so this is the initial ground state of bromine. So dia ada 1 je unpaired electron. Kalau tengok from the Lewis structure, by right there are 3 bonds. 3 bonds, that means bromine should prepare 3 unpaired electron. But currently at the moment, bromine has only 1 unpaired electron. So nak prepare 3 unpaired electron. So nak prepare 3 unpaired electron. So that means one of these, okay, from the p orbital will be overlap will be promoted. Okay, so it become this excited state. So dapatlah 3 dekat situ kan, 3 unpaired electron here. Okay, alright. So how about these two? Jangan usik, biar dia begitu. Okay, let it be, because these two represent the lone pair. Right, so later on fluorine will overlap. So we have 3 fluorine will combine with the electron from bromine. So that is how you prepare the orbital diagram for bromine for this case lah. Okay, alright. So how do you draw the orbital overlap? Sama saja. So it has 5 electron groups kan. So it should be trigonal bipyramidal kan. So you should have 5 electron group lah. So how do you draw 5 electron group? 5 lobes, 5 cuping 1, 2 orang. Label BR. Ish. Okay, mana nak lukis? 1, 2, 3, 4, 5. Okay, so this is BR. Okay, don't forget the electron, guys. Okay, there are 3 bonds and 2 lone pairs. So this should be the fulfilled orbital just now. Okay, so this belongs to BR. So there should be no terminal atom on these loops. Yang ada hanya 3 saja. Okay, biru. Fluorine kan, because they combine dengan siapa? Fluorine. So fluorine should be inilah. Should be p orbital. Okay, alright. So don't forget the electron from fluorine. Okay. Nanti awak redraw balik lah ya. Okay. Okay, so all of these are sigma bond. So these two are lone pair. Okay, sama tak dengan kita punya Lewis structure? Sama. Okay, is it the same as our orbital diagram? Yes, it is. Okay. Habis. Okay, patah balik. Psycho. Okay, patah balik. Okay. Dan. Okay, alright. So last but not least will be multiple bond having double and triple. So how do we distinguish this multiple bond with lone pair and single bond? Right? Okay, question. Any questions so far, guys, related to lone pairs?
No, madam.
Okay, good. Lagi.
Jelas.
Okay, bagus.
No, madam.
Okay.
Alright.
Okay je.
Okay, alright. Bagus. Thank you for the response. Okay, so we shall move to the next category, which is molecules having multiple bond. But before that, let's just look at the example. Okay, show. Ini contoh soalan. Kalau dalam exam dia bagi show the hybridization of the central atom in the molecules below by using orbital diagram. Nampak? Dia mention orbital diagram. Then you bagi orbital diagram lah. You jangan, tak payah susah-susah nak bagi orbital overlap. Okay, and then you have to determine its molecular geometry and bond angle. This is VSEPR. Okay, all right. So you have the hybridization and also VSEPR. So kalau for your practice, just for your practice, let's say for your tutorial ke apa, I would encourage you, even though dia minta the hybridization for the orbital diagram, you prepare juga for the lobes tu, for the orbital overlaps. Okay, just nak practice yourself untuk tutorial, but in the exam just follow ataupun prepare what the question wants. Tak payah nak buat extra kerja dekat situ. Banyak masa tu, banyak lagi nak digunakan untuk soalan-soalan yang lebih susah kemudian. Okay, alright. ASCL3, ASCL5. Okay, so you have to prepare the Lewis structure. Mesti kena ada Lewis structure. Okay, so ASCL3. So this is ASCL3. So this will be your Lewis structure. Okay, your Lewis structure, and then you can the electron geometry is 1, 2, 3, 4. So the electron geometry is tetrahedral. Okay, dia adalah tetrahedral, then you transform into tetrahedral shape. So this is already transformed lah. Okay, this is a transformed version. This is already tetrahedral in shape, but for molecular geometry, it is trigonal pyramidal. Focus on the Cl and the central. Okay, all right. So the molecular geometry is trigonal pyramidal. And what else? Apa lagi? Nama benda lah ni. Type of hybridization. Okay, just count the number of electron group on central. So 1, 2, 3, 4. So we have 4 electron group. So it should be Sp3. And then as you can see, you have 1 lone pair there. Maksudnya, bila you buat hybridization tu, you kena bear in mind that one of the orbital in the hybrid orbital should be a full-filled orbital. Okay, so tu kena take note lah benda-benda macam tu, sebab that's why saya kelaskan dia all bonding pairs, and then if dia ada lone pair, and then kalau multiple bond. Okay, alright, so this is how arsenic come from group 15. Okay, that's why it has 5 valence electrons. So again, it has 3 unpacked electron already. So all the Cl can by right can form bond with arsenic. But still, okay, arsenic will hybrid. Okay, will undergo hybridization, because if not, the geometry will be inaccurate. That's the reason why, even though dia dah cukup the unpacked electron, but still dia undergoes hybridization. So maybe if without hybridization, the bond angle will not be the same. Okay, so that's why they still kena go hybridization. So macam ni lah. This is how you should prepare the hybrid orbital for the central. Just nak bond angle ke? They mention about bond angle. Yes, the question mentioned about bond angle. Okay, I would highly suggest you, if you are asked for the bond angle, you have to show the bond angle. Okay, this is less than 109.5. Don't do this. Saya rasa tak sesuai just bagi macam tu. Kita nak tahu, student tu tahu tak beza 109 less than 109.5 ni, sometimes dia buat macam ni. Okay, which is wrong. Dia mesti between memanglah ini between the bond, tapi dia sebenarnya bonding closer to one another. Okay? Alright, so sama lah for AsCl5. So you kena count the number of electron group dulu. So we have 5 electron groups. Okay, 5 electron groups, that means it is Sp3d. Ada lone pair tak? There's no lone pair, guys. That means all of it should be single electron. Okay, promote ataupun excited and then combine. So all of them should be unpaired. Okay, all right. So this is trigonal bipyramidal in shape molecular geometry. Okay, semput. Ui, dah nak habis time tu. La ilaha illallah. Kita kena habiskan this hybrid by today, okay? Alright. Sebab kita dah nak by right this week kita kena start the topic 4. But as you can see, belum habis, and we have one more subtopic to go. Okay, so next week kita kena finish up this topic. Okay, alright, get ready guys. The best part yet to come. Okay, belum lagi, so bertenang dulu, minum air sat. Bismillahirrahmanirrahim. Yang ni yang critical sikit Right, the multiple bonds. Dia ada soalan ke tu? Oh, sedapnya lagu bunyi. Siapa tu? Huda? Oh, Huda. Oh, sedap dengan lagu. Huda tak ada kat situ ke? Huda, Nurul Huda. Your mic is on. Okay, please mute your mic. Kita continue sambil diiringi lagu itu. Okay, alright. Sp2 hybridization. Okay, let's have C2H4. Okay, this is another good example because we have two central there. We have two carbons there, and therefore we have two central. Okay, alright. Wow, dahsyat tak? Okay, alright. So, C2H4, you have to draw the Lewis structure first. Okay, you have to draw the Lewis structure first. So this is Lewis structure for C2H4. Okay, alright. So we have double bond between the carbon and 4 bonds. Okay, carbon and hydrogen. So each carbon is bonded to 2 hydrogen. So this is C1, C2. Let's just label it as C1 and C2. Okay, central number 1, central number 2. Okay. Ini pun simetri. Simetri maksudnya dia ada this carbon has 2 hydrogen, the second carbon also has 2 hydrogen, and then they are attached to one double bond. Okay, kita panggil simetri lah. Maksudnya bila kita prepare for C1, that means we can imagine the C2 also having the same orbital diagram. Okay, alright. Ataupun saya boleh buat yang baru kot, so that you boleh nampak better lah kan. Okay, let's start from the beginning. C2H4. So this is basically your Lewis structure kan. Okay, katakanlah kita dah siap determine the geometry and whatnot. So this is your Lewis structure. Okay, alright. So we have C1 and C2. Alright. So how do we determine the electron, the type of hybridization? So since we have 2 central, that means you have 2 hybridization. For each central should have its own hybridization. So C1, the hybridization is Sp2. How do we know so? Senang je, calculate. Okay, focus on the C1. So we have 1, 2, 3. That is directly attached to the central, the first central. So 3, it shall be Sp2. Okay, same goes to C2. Pun juga Sp2. 1, 2, 3. Sp2. Okay, right, buat kat sini lah. C1 is Sp2. C2 is also Sp2. Okay, alright, let's delete. Okay, so now let's prepare the orbital diagram. Okay, orbital diagram, carbon, the ground state for carbon. For C1 lah. Okay, for C1, okay, so Sp. The carbon come from group 14 kan. Group 14, that means it has 4 valence electron. 1, 2, 3, 4. Okay, right. So excited state. Excited state. Saya pakai short form lah ya. Excited state for C1. Okay. Alright, so it shall be, okay, dia tak mungkin, you tak boleh remain dia sebagai dia fulfilled macam ni. Walaupun yes, nampak tak dia ada 2 unpaired. This is for hydrogen dekat situ. Okay, just kita buat siap-siap. Okay, this is sigma guys, this is sigma, and this is sigma, this is pi bond. Betul tak? This sigma, sigma. Yes, that means we have 1 pi bond between the 2 carbon. Alright, so by right, kalau kita tengok dekat sini, carbon, sebab dia ada sigma kat situ kan. So carbon, each carbon should have 3 unpaired electron. Sebab dia ada 3 sigma bond. So at the moment, carbon has only 2 unpaired electron. So nak kena prepare 3 kan? 3 unpaired electron. So dia kena excite. Okay, dia tak mungkin biar dia remain macam ni. Sebab the carbon does not has any lone pair on it. So dia tak ada lone pair. So jangan biarkan dia fulfill. Fulfill is for lone pair. Okay, alright. So this one will be promoted. Color lain. Okay, so dia akan jadi S. Kat sini yang best part dia Nampak ya? Begini, begini, begini. Okay, selalunya kita akan short ambil combine all of the p orbital. Itu yang you selalu, itu yang paling bahaya. Okay, remember apa yang kita nak, what we want is Sp2 guys. Kita nak Sp2. That means kita hanya combine this part saja, leaving behind this one electron in the p orbital. Okay, so this is the hybrid. Kenapa macam tu? Okay, so dia jadi Sp2. Then we have P unhybridized orbital. So this is what we call unhybridized orbital. Okay, so we have one electron in this P unhybridized orbital. So you boleh imagine tak ini akan form apa? This one will form the pi bond. Okay, this one will be your pi bond. Iris. Okay, padam mana yang tak perlu. Okay, imagine. Sepatutnya kita kena ada 2 carbon kan? So saya buat lagi satu. This is for C1 and this is for C2. Saya buat exactly the same. So ground state for C2 S2, 2, 3. Okay, and then excited state C2 sama saja dia punya keadaannya begitu. P S1 after dia dah excited kan dia jadi begini, and then the combined version, the hybrid version for C2. Okay, alright, so only these these orbitals okay will be combined, so dia akan jadi Sp2. Leaving behind this P unhybridized orbital. Faham tak? That's why you kena tahu this what do we call this? This type of hybridization dulu, sebab this will guide us on the hybrid part. Kalau tak, you akan ada tendency you dah, macam biasalah bila kita buat yang awal-awal tadi, kita lompat, kita combine semua, betul tak? Kita combine semua. But for multiple bond, you akan tinggalkan based on the number of pi bond available in the molecule. So in this case, kita ada satu pi bond kan between the carbon. So that means kita ada for each central, in this case carbon, you kena ada satu unhybridized p orbital. This is for C1 and this is for C2. Okay? Faham tak? So ini yang akan form pi bond guys. This will form the pi bond. Okay, jom kita buat macam cantum-cantum tadi, macam awal-awal yang serabut tu tadi. Okay, alright. So tengok, okay, saya draw lagi sekali so that kita boleh nampak clearly yang mana sigma, yang mana pi. Alright. Okay, so ini sigma kan? This is sigma, sigma, sigma. This is sigma, this is pi. Okay, alright. So Sp2, okay, kita nak pair dia dengan siapa? Okay, look at the first, okay. Yang ni is between hydrogen, betul tak? Hydrogen akan masuk. Katakanlah this is for this one. This hydrogen is for this first hydrogen here. And the second hydrogen for C1 will be this one. Okay, these two akan form sigma, sigma. Betul tak? Betul kan? Betul ke tak betul? Betul. Okay, so saya sendiri jawab. Okay, alright. Same goes to C2. Cuba fokus pada C2. Kita nak settlekan all the hydrogen first lah. Okay, let's settle the hydrogen first. Okay, so hydrogen. So this sigma bond, okay, kita ada 3. Untuk C2 pun sama. So katakanlah kita form this hydrogen, dia akan form bond with this C2. Okay, alright. So this will be another hydrogen, another sigma. Yang ini. This is for C2. Okay, dah settle for all the hydrogen and all the sigma involving hydrogen. Okay, now nak go between the carbon. Alright, so let's look at the carbon pakai color lain biru lah. Okay, this one. Ni kan sigma ni. Nampak tak? Ni sigma. It's between carbon and carbon. Betul tak? Alright. So this one, this one more electron on the hybridized orbital. This will combine. This will overlap, guys. This is also sigma. Okay, yang ini, this one. This is the sigma. Okay, we can represent this using this orbital diagram. Okay, teng teng. So yang ni, yang last, the unhybridized p orbital here. Okay, these two will overlap because this represent the pi bond. Okay, so pi bond between the two unhybridized p orbital. Right? Okay. Okay, faham? Saja je. Dekat soalan dekat yang ni C2H4, nampak tak? Dia tunjuk satu je C1 kat situ. Sebab dia assume the same orbital diagram for the C2. For C2 yang ni lah. Pandai awak lah kat situ ya. So the same orbital diagram for C2. Sebenarnya begini memanglah sama, tapi kalau you tunjukkan, you lebih nampak. Nampak tak? Nampak tak? Ke ada yang tak nampak?
Nampak.
So ni lebih detail lah, ni lebih bagus lah. Okay, alright. So you ada C1. So this is for C1. This is for C2. So everything kena sama. You guys faham tak? You kena tally tau. Orbital diagram, Lewis structure and also your orbital overlapping. Okay, here come the best part. Okay, alright. Nak buat kat mana supaya tak serabut. Okay, cuba. Saya kena fikir ni. Kadang-kadang tak faham terus give up. Don't give up. Sebab multiple bond ni favorite. Okay, alright. So, how do we draw the orbital overlapping? Okay, let's go one by one. Let's go for the first central first, guys. Okay, so the first central is Sp2 kan tadi kan. This is also Sp2, betul tak? Alright, so how about how many lobes? Okay, how many lobe shall we draw for Sp2? So senang je, 2 tambah 1, 3. 3 lobes kan? Okay, buat macam ni. 1, 2, 3. Maafkan saya atas lukisan saya ini. Alright, so this is for C1 guys. Okay, this is for C1. C2 pun buat cara yang sama tapi make sure dia overlap dekat situ. But you representing the Lewis structure. So bond tu dia mesti tunjuk overlap. Okay, alright. Okay. Prefer Lewis structure juga ya. Okay. Sabar. Okay, kena ada this electron and don't forget this electron also. Okay, C1 and C2. So this is C2. Okay, just kita padam pakai color lain lah nak tunjukkan. Okay, so for C2 let's use red color. Okay, alright. So for hydrogen, okay, let's use green color. Okay, hydrogen should be bulat lah ya. Okay. Label guys, label. Kenapa kat situ? Kan kat sini. Okay, alright. Okay, done. All the sigma bonds are shown. Okay, how about the pi bond? Ni semua sigma ya guys. Ni sigma, and also this one is also sigma. Semua dah kita tunjuk for all the sigmas. Okay, how about pi bond? Okay, pi bond, remember it is unhybridized p orbital. Okay, it is unhybridized p orbital. Remember unhybridized p orbital? Px, Py, Pz. Yang ni, ini unhybridized lah. Ini namanya unhybridized. Dia independent. Okay, so normally kita akan draw Px, Py, Pz macam tu kan. Okay, sama. So we draw the same way. Okay, so normally kita akan buat ke tak nak pakai color ni lah, pakai color this one. Okay, right. buat tegak. Tapi it should include the whole p orbital lah. So dia include atas dan bawah. Sebab originally p memang macam ni. Okay, so dia should be atas dan bawah. Complete p orbital. Begitu. Okay, alright. So here okay. Okay, so one electron from C2. Okay, alright. So nak tunjuk dia overlap, macam mana nak tunjuk dia overlap? Inilah limitation bila 2D tu. Sebenarnya it should overlap sideways. Betul tak? Remember we have learned about pi orbital last time? Okay, dia akan overlap sideways. So to show the overlapping, kita kena connect dia macam ni lah. Buatkan connect dia macam tu. Ya, begitu. Okay, dia akan connect atas dan bawah. Dia akan overlap atas dan bawah. Dia bukan overlap macam ni. Dia kena overlap both. Okay, up and down. So maksudnya you should have these two. Dia datang one set begitu. Okay, kena tunjukkan atas dan bawah. Right? Ya, begitulah rupanya. This is your pi. Label guys, pi. So pi lah, ada satu pi lah. Okay, pi. Tapi dia overlap atas dan bawah. Right? Faham ke tak faham? Okay, another example sebelum kita buka open.
Ada elektron dekat hujung tu apa?
Yang mana ya? This one. Mana?
Yang untuk yang warna kuning tu.
Kuning. Kuning mana? Sini.
Tak nampak boleh dia tunjuk.
Ni mana ni? This one. Is it?
Bukan dekat yang figure yang dah banyak-banyak tu.
Agak banyak. This one? Orbital overlap? Warna kuning.
Kan ada tu kat atas. Macam elektron.
Elektron? Ni ke? Is it this one? Mana?
Dekat atas tu madam ada tunjuk yang macam 1, 2 macam tu. Dekat each lobe tu, kat hujung lobe.
Each lobe, this one yang warna kuning ni. Ni ke? Yang ni ke? Ini nak connectkan dia, nak show the overlapping. Sebab obviously dia tak overlap, betul tak? Okay, obviously dia tak overlap kan? So sebenarnya dia kena overlap. So nak tunjukkan sebenarnya dia tu overlap, kita connect these two by using this line. So menunjukkan dia overlap lah. Faham tak? Menjawab tak soalan saya? Kalau macam ni, okay ada pun ni. Kan jauh ni nak tunjuk dia overlap. Jadi kita connect dia dekat situ. Okay, kita connect them. So tak payah buat elektron dekat sini pun tak apa. Buat dekat setiap dalam loop tu. It's okay. Okay, tapi dia kena connect atas dan bawah. Inilah yang saya try tunjukkan ni kat sini. This represent the pi bond. Ni kena label ni sebenarnya. Pi bond, this is sigma. This between this carbon, kat tengah ni will be sigma. Yang unhybridized, this will be unhybridized. Atas dan bawah. When these two overlap, atas dan bawah, so that would form one pi bond. Okay, one pi bond. Faham ke? Menjawab ke soalan awak? Ke saya tak dapat tangkap ni?
Maksud saya yang dekat lobe yang warna kuning tu, hujung dia ada elektron.
Hujung dia ada elektron. Ni lah, ni
Memang kena letak.
Kena lah. Sebab nak tunjukkan this one, ni elektron ni. Elektron tu dia duduk dalam p orbital macam setiap satu ni kan. Yang ini dia punya lobe dia mana? This one. Salah satu antara ni lah. Betul tak? Ni elektron dia belong to this lobe. This one elektron dia belong to this lobe.
Madam, yang kat tengah tu bukan madam dah letak ke?
Mana?
Yang dia connect antara tu
This
lobe
one
tu.
ke?
Bukan yang kat atas tu. Yang kat tengah atas tu.
Yang tengah.
Atas sikit. Bawah yang ada P tu. Nampak tu. Yes, tu.
Ni.
Itu bukan elektron ke madam?
Bukan. Ini pi. Ini saya label pi.
So kalau madam,
pi.
kalau kita tak nak tulis dekat lobe tu, kita just buat antara connector tu boleh ke macam dalam
buat
slide?
Macam ni? Boleh?
Yep.
Boleh? Tak ada masalah.
So
Okay?
bawah kena letak juga ke? Yang
Tak
bahagian
payah,
bawah
you
tu?
either buat dekat atas ataupun dekat bawah.
Oh, satu je lah.
Tapi sebenarnya kalau betul-betul dalam orbital tu, the electron ni dia keep moving. Dia boleh duduk atas, dia boleh duduk bawah. And then one more thing, you tahu tak, dia rotate tau. This molecule, dia keep on rotating. Dia bukan static je macam tu. Okay, dia keep on rotating. Tapi understood lah, bila you tunjuk ke atas and then kita tahu yang the electron dia the electron dia vibrates. Okay, and the orbital pun dia keep rotating. So sebenarnya dia tak static dekat sini. So that's why kita tunjuk still 2 macam tu.
Kalau kita gatal tangan madam sebelah separuh kat atas, separuh kat bawah boleh ke?
Boleh as long as dia duduk dekat loop yang ini. This unhybridized P. Boleh, tak ada masalah. Okay, tapi janganlah gatal. Okay, buatlah ikut yang ni lah to be safe lah, to be safe. Okay, so kalau kata nak buat kat sini satu, dekat sini satu. Boleh. Kalau ikut kita punya understanding tadi that they rotate and eventually they overlap. Bukan eventually, dia memang overlap. Okay, dia memang overlap. So dia punya region dia tu lebih besar lah. Dia lebih besar, dia boleh atas, dia boleh bawah dekat situ. Okay, sebab region dia satu set, atas dan bawah. This is what we call unhybridized P due to PX, PY, PZ. Ini pun kita represent satu saja sebenarnya. By right, we should have PX, PY, PZ. Can you imagine if we have 3 of them dekat gambar yang sama? Serabut bye. Okay, so just tunjuk satu sajalah. Tunjuk satu saja. Okay. Faham ke? Saya menjawab soalan. Ini pi kod-kod yang ini pi. Ini yang elektron yang duduk dekat tu. Kena tunjuk elektron tu. Okay, any question? Ini penting sebab ni antara favorite question. Dalam soalan exam dia akan keluar sekali dengan lone pair dengan multiple bond. Tada! Okay. Contoh, lagi contoh triple bond. So can you imagine if you have triple bond, that means you should have these two. Unhybridized P. Boleh imagine tak? 2 unhybridized P. Maksudnya bila you akan combine hanya 2 ni saja. Leaving behind these 2. Alamak, aku tujuh lah. Leaving behind these 2 unpaired electron in the P orbital. So you ada sp saja. That's why you kena first and foremost you have to determine the type of hybridization. Contohnya kan, this is your Lewis structure. So C1, 1, 2. There are 2 electron groups on C1. So dia adalah sp. Same goes to C2. 1, 2, sp. Nampak tak? So kita prepare untuk C1. Sama juga. C2 pun rupa dia exactly the same as this. Okay, it's exactly the same as this. So ini nanti hydrogen akan masuk. Yang this one, this will form between the carbon. So lukisan yang sama dekat sini, sp dekat situ. Sp, dan this one hydrogen akan masuk dekat situ. So then we have 2 p orbital. P unhybridized p orbital. Okay, so this later on dia akan form first pi bond, second pi bond. Sebab kita 2 pi bond, nampak? This is sigma guys, this is pi, this is pi. Okay, alright, so boleh imagine in terms of orbital diagrams. Okay, right. So this, again saya dah tunjukkan tadi. So this one will overlap with this orbital. So this is the sigma between the carbon. Okay, sigma between the carbon. And these two, okay, will form pi bond between the carbon. Okay, jom tengok orbital diagram dia. Padam dulu semua. Nampak tak? So you boleh imagine tak you akan ada 2 atas dan bawah ni. For C1, atas dan bawah. This is for the first pi bond. Same goes to C2. So these two will overlap. Okay, the second pi bond, sebab kita ada 2 guys. Okay, the second is the yellow one. Yellow, these two will overlap. Buat sengit sikit kan. So these two will overlap. Don't forget the electron. So this is the second pi bond. Second pi bond, okay. Alright, so the rest are all the same. So this is the sigma between the hydrogen, sigma between the hydrogen for C1, and sigma between the hydrogen for C2. Okay? Faham ya? So boleh imagine, so bila you nampak je ada when we have multiple bond, especially triple bond, first kali you akan berdebar. Bila you berdebar, okay, you bertenang. Bila you bertenang, then baru you buat. Okay, berdebar itu normal. So you buat macam biasa, and then later tu bila you nampak ada pi bond, that means you boleh imagine there should be unhybridized p orbital, because this unhybridized p orbital will form the pi bond. Faham ya? Okay. Right. So, contoh ini adalah favorite question, pernah keluar dekat partial, nampak tak C dengan N dekat sini. Okay, kan saya pernah cakap normally the central will form the central will form the hybrid, tapi if the terminal form the terminal is bonded with the terminal is multiply bonded with the central, this terminal will also form hybrid, guys. Okay, terminal yang form multiple bond dengan central, dia pun akan hybrid. Please take note on that. Itu satu lagi information penting yang you kena tahu. Okay, alright. So how do we know this carbon, dia punya formation of hybridization? Senang aja, 1, 2. So this one would be Sp. How about nitrogen, guys? Nitrogen, 1, 2. Sp. Okay, lagi sekali saya repeat sebelum kita end our session. For terminal atom, normally central will form the hybrid. Only central will form the hybrid. But if the terminal atom is either doubly bonded or triply bonded with the central, that means that terminal will also form hybrid. Bila dia form hybrid, maksudnya macam mana, how do you determine the type of hybridization? Sama juga, you determine the number of electron group surrounding the terminal atom, that particular terminal atom. Okay, that means bila you imagine nanti, nampak from this one, H triple bond CN, HC triple bond N, you boleh imagine untuk nitrogen for the orbital diagram, dia akan ada full-filled orbital. Dia tak? Sebab ada lone pair kan. This is what we call full-filled orbital, and then begitu. Sp kan. So dia akan ada begini. This is Sp. Okay, how about the carbon? Carbon ni sebab dia ada triple bond kan, you boleh imagine nanti dia akan ada begini, dia tinggal. So dia punya S, dia tak ada lone pair kan on it. So Sp. Okay, alright. So nanti try connect dan beginilah buat untuk N. So this is N. Okay, and then connect. Nasib baik dia example. Okay, you boleh try redo balik lah soalan ni. Ada. Okay, alright. So that's all. Unfortunately tak habis